Today's lesson is on imaginary numbers and complex numbers. By the end of this lesson, you should be able to simplify square roots in terms of I, simplify expressions involving large powers of I, solve incomplete quadratic equations by taking square roots, and apply the rules of complex numbers to problems involving addition, subtraction, and multiplication. This part of this lesson is on complex numbers, which is the fourth bullet down. So this is a continuation or a part 2. Complex numbers can always be thought of as a combination of a real number with an imaginary number, and will have the form a plus bi, where a and b are real numbers. We say that a is the real part and bi is the imaginary part. These two parts, the real and imaginary, cannot be combined. So if you just have an imaginary, we call it imaginary. But if you have a real and imaginary, we call that complex. Like real numbers, complex numbers can be added and subtracted. The key to these operations is that the real components can be combined with the real components, and imaginary with imaginary. So we're going to look at adding and subtracting first. So the real component with the real component. So when I look at this complex number, -2 is the real component and 6. So I'm going to do -2 plus 6. And then I'm going to do 7i plus 2i. So this is the real part. And this is the imaginary part. When I add them, so -2 plus 6 is 4, 7i plus 2i is 9i. I get the answer of 4 plus 9i. And make sure that every time you write a complex number, you write it in a plus bi form. Okay? So the real part has to come first, and the imaginary part has to come second. Subtraction is always going to be a little bit more difficult, but just be careful. So I have 5 minus 2 and 3i minus -7i. Two negatives make a positive, so 5 minus 2 is 3, 3i plus 7i is 10i, so my answer is 3 plus 10i. So subtraction, make sure you give this subtraction sign to both parts, okay? That's why I think it's easier to write the real parts together and the imaginary parts together. So why don't you pause the video and do letter C and then continue and see if you did it right. Hopefully you did it right and you got an answer of 5 plus 3i. Now, adding and subtracting complex numbers is straightforward because the process is similar to combining algebraic expressions that have like terms. Exactly. The complex numbers are closed under addition and subtraction. For example, when you add or subtract two complex numbers, the result is a complex number as well. So that's very important for you to know. But is it closed under multiplication? So we're going to look at the next 3 examples, which are all multiplying. The first one is a binomial times a binomial. So just like when we had algebraic expressions, so if we had x's instead of i's, how would we go about this? And we would use the box method. So since I have a 2 by 2, I'm going to make a 2 by 2. So 3 plus 5i, 7 plus 2i. And multiply. 7 times 3, 21. 7 times 5i is 35i. 2i times 3 is 6i, 2i times 5i, and this is where people make the mistake. 5 times 2 is 10, but what is I times I? I squared. Now we know from previous lessons that we can't have I squared. I squared simplifies, and I squared is the same as -1. So what is 10 times -1? And that would be -10. So combining my like terms, I have 21 minus 10, which is 11. And I put the real part first, very important. And then I have 35i plus 6i, which is 41i. And again, it has to be in a plus bi form. All right? So hopefully you remember on the second one, squared means to write this twice. So this is exactly like this one. So go ahead, pause the video, try B, try C, and then continue when you're ready. Well, I hope for part B you got 5 minus 12i, and for part C you got negative 17 minus 17i. Let's continue. Conjugate of a complex number, and we've talked about conjugate in the past. A conjugate is where we change the sign in the middle, like this. So a plus bi and a minus bi. Notice they are both conjugates because a minus bi is the conjugate of a plus bi, and a plus bi is the conjugate of a minus bi. So we are going to, in exercise 4, show that the product of a plus bi and its conjugate is a real number. So something very special happens when we multiply something by its conjugate. And remember, product means to multiply. So what is the conjugate of a plus bi? A minus bi times a plus bi. So again, I'm going to use my box to do my multiplying. So a plus bi, a minus bi. A times a squared. A times bi is abi. A times negative bi is negative abi. And negative bi times positive bi is negative b squared. And that's the part people get wrong. And then I squared. Now we remember that I squared is negative 1, so a negative and a negative make a positive, so this is b squared. We also notice that these middle terms cancel. So my answer to this problem is a squared plus b squared. This is real because there is no I in it. So there's no imaginary number, so that means it's a real answer. So when you multiply any complex number by its conjugate, you are always going to get a real number. So under what conditions will the product of two complex numbers always be a purely real number? When you multiply by its conjugate. So let's pick one. I don't know. Let's do 6 plus 5i. Its conjugate would be 6 minus 5i. And over here I'm going to use my box. So 6 plus 5i, 6 minus 5i, I get 36, 30i, negative 30i, and I get negative 25i squared. Well, I know that these cancel, and I know this negative 25i squared turns into a positive 25, so 36 plus 25 is 61, which is a real number. No imaginary, no complex. All right. So in exercise 6, it makes this one really easy because if you know that it is purely a real number, then you know you have to have conjugates. Is 1 conjugates? Nope, those are not conjugates of each other. 2? Nope. 3? Yup. 4? Nope, because the signs are the same. The signs have to be different or opposites, and you need to have exactly the same thing. So your answer to number 6 is 3. Okay? All right. Why don't you pause the video and try exercise 6. You're going to multiply these two first, then multiply these two, and then add them together. Good luck. Continue the video when you have done so. Well, hopefully you got the answer of negative 29 plus 7i. If you don't understand something, please make sure you ask in class. Good luck with complex numbers.